Okay, I wanted to do a quick review of what we've done so far. You're going to have a Module 1 test the next time I see you. So A through L kids, we're going to have a test on Monday. M through Z kids, you're going to have a test on Tuesday. We have covered almost everything. There's a couple things that we're going to talk about on this video that we haven't talked about, but it is fairly simple, and I think y'all get it. I will send this in your Google Classroom. So if you want to follow along as I do the video or go back and try it yourself and see how you do, I think that's a good idea. But this is just a review. So a couple of things. In the previous video that I'm attached to this post is a video talking about linear pairs and vertical angles. So what that is linear pairs are 2 and 3, angle 2 and 3 added together are going to be a line, which is 180 degrees. So in this example, it gives us angle 2 and angle 3. So angle 2 is 2x plus 5, and angle 3 is 85. Those two together, again, linear pairs, that's a vocabulary term you need to know, are a line. So I'm going to go 2x plus 5. And you may be able to do this in your head, and that's fine. I'm going to go kind of quick because you can always pause the video, go back to it, or whatever. So what I'm going to get here is I'm going to get 2x plus 90 after I combine like terms, subtract 90, and 2x equals 90. And when I divide by 2, x is going to be 45. Okay, so if you want to do the review before this video, I think that's a good idea, and then go back and see if you got it right. So there's 45. Okay, number 2. Again, in the video before, I talked about vertical angles. So vertical angles are angles, right? The X tells you vertical angles is going to happen. So this talks about angle 1 and 3. So how are 1 and 3 related? Those are vertical angles. Okay, so that's just a simple little vocabulary term. Okay, so there we go with that one. All right, this one, don't get all crazy about, you read this, it says the law of detachment and law of syllogism. Don't worry about that. I know we have not talked about this, and we won't. But all it's basically, there are laws that include reasoning, which if you have, you can answer this question. So it says, if a person drives a car in the United States, that person must drive on the right side of the road. So if Kaylee drives in a car in the United States, then what is the reasoning? Well, the reasoning is she must drive on the right side of the road. So I don't think we need a lesson on that to just understand that that's what that means. But that's, if you look on your Savaz, and I'll give it to you, then that's what it's talking about. Okay, right here. It says, what is the length? Which is telling you distance formula. Because I got 2 points, and find length, that's distance formula. Now, for me, I like to draw a diagram, even if it may not help. I like to draw a diagram. So this is negative 2, 5, so negative 2 is here, and this is just a sketch. Don't take it as exact, and there's negative 2, 5 would be here. 4, 5. 1, 2, 3, 4. 5 is right here. So you're trying to find the length of that. Well, that's a horizontal line. Okay, and the key is both of these have the same y value. Or you just count from negative 2 to 4. So that length is going to be 6. Okay? Now, if you don't recognize that, that's fine. That's okay. We're just going to do x1, y1. All right, and this is 0.2. So 4 is going to be x2, and 5 is going to be y2. Then we're going to put it in the distance formula. Remember, distance formula comes from Pythagorean theorem. Let that help you kind of remember what it is, because on test, you're going to have to know distance formula if you're going to use it. So the distance formula is x2 minus x1. So I'm going to go 4 minus negative 2, which is a plus I'm going to leave it like that for now. So if I go 4 minus -2, I got to go 5 minus 5, which is going to be 0. It makes sense because I didn't go up any. So minus and negative is plus and positive. So if you want to go ahead and erase that, put plus. Well, that's how I get my 6. And I'll put 0, but that's going to be nothing. And 6 squared is 36, and the square root of 36 is 6. So if you choose to use distance formula, either way you're going to get 6, or if you want to use a graph, you're going to get 6 either way with that too. Okay, so there's that. All right, next one. Conditional statement. We did talk about this briefly. A conditional statement is an if-then. So this conditional statement is if a number is odd, then it's an integer and a prime number. And a prime number. That's important. The question is, what is a counterexample? So counterexample we have not talked about, but it's pretty self-explanatory. It's an example that counters the conditional statement. So the counterexample is an example that shows that the statement, in this case the conditional statement, is false. So an example of that, right, this conjecture, the polygon with diagonals has 2 fewer diagonals as sides. Well, an example that would negate that would be a pentagon. As you increase the side, then that becomes not true. All right, so for our example, it says if a number is odd, then it is an integer and a prime number. We do have to know what prime number means. Prime number factors 1 in itself. So you got 3. The only way you get 3 is 1 times 3. 5. The only way you can get 5 is 1 times 5. So those are the prime numbers. So you got to understand that. But a counterexample would be a number is odd and it's an integer and a prime number. Well, 2 is not odd. So that cannot be a counterexample to that because that doesn't fit the statement. 7 is odd. 9 is odd. Now, is 7 prime? Yes, it is. So that's not a counterexample. A counterexample is one that makes this false. So 9 is odd, but it is not prime because the way you would get 9 is 3 times 3. So it has more factors than 1 and 9. Okay, so that's a counterexample. So we haven't talked about it, but there's a quick example of what a counterexample is. Again, we did talk about conditional. Conditional statements are if-then. The if part is the hypothesis. The then part is the conclusion. So this question asks for what is the hypothesis of the conditional statement. It's just what goes with the if. So in this case, a number is odd. Next question, same statement, same conditional statement, but then it asks for the conclusion. Well, the conclusion is the after the then. So it is an integer and a prime number. So this says a number is either, that's not what and means. And means both. So this is both integer and prime number. Okay, right here. Now you got to pay attention to this because this is going to look very similar to the test you're going to take. You've got to answer this in the correct way or it's not going to count it correctly. So it says, what is the midpoint of HN? So HN, H is here, N is here, and there's my line segment. So segment HN. So the midpoint, I think we're okay, is this thing right here. I think we understand that, right? 3 to the left, 3 to the right. But don't put K. It wants an actual number. So when you do the test, it's going to have different numbers and different letters, whatever. Don't put the letter, put the actual number. So you're going to put 0 right there. Okay? So be careful of that when you get that on the test. All right, same thing over here. And I actually, to be honest with you, I messed this one up too. It says HJ, which is here to there, plus JM, which is there to there, okay? And what I put the first time I did it, I put equals HM. But at the end, it counted it wrong. It doesn't want the actual statement. It wants the actual number. So when you get to this question, it's going to be on your test, different numbers, different letters. Put the actual number, which in this case would be 5. So you would put 5 there, and then you move on. Okay, so be careful with that when you see that question on your test. All right, next thing, it says distance. So when it says what is the distance, automatically you should be thinking distance formula. This time I'll actually write out the distance formula. It is in your notes, but if you need it right there, it is. So it comes from Pythagorean theorem. Right, we proved that. So just for the points F and G, and right there's your coordinates. It does say round to the nearest whole number, so pay attention to that. We'll call this X1, Y1. We'll call this G, the second point, X2, Y2. So when I plug that in, again, I'm going to go fast, but you can always stop it and go back and look at it again. X2 minus X1, that is 14 minus 6. Y's, right? Y2 minus Y1, 19 minus 4. So as I simplify this, again, the idea of rounding to the nearest whole number, keep that in your mind. That's 8 squared, 19 minus 4, 15 squared. So if you square that, that's a 15. I get 64 and 15 squared is 225. So I add that. We'll come over here. Square root of 287. Sorry, 289. If you punch that in the calculator, I'm not going to punch it in, but if you punch that in the calculator, you get around 17. So you would round the whole number, and the distance of that one would be 17. Okay, so punch that in the calculator if you don't trust me, but that is going to be rounded to the whole number is going to be 17. 11. Okay, the word bisect. It is a vocabulary term. Bisect means cut in half. So if ray BD, we know what a ray is, right? A end point, and it goes forever in one direction. Bisects ABC. So again, I'm a diagram person. And it doesn't say what the angle looks like, and it really doesn't matter. But I have an angle ABC that is bisected by BD. Right here's B. And so I got a ray that cuts that angle in half, BD. So that's what this statement means. If it cuts it in half, go back to notes. That deserves one arc, and that deserves one arc, because that means they're the same. So it bisects it. They are the same. So the measurement of DBC is x plus 7. DBC is this smaller angle down here. And then ABD, which is this other angle right here that got bisected, right? The red one got bisected, which means these two are going to be the same angle. So that's 2x minus 11. Hopefully you can see that color. If it truly bisected, right, arcs mean they're the same, I'm going to make them equal to each other. So 2x minus 11 is going to equal x plus 7. Those two angles are equal. You can just solve that little problem. So just real quick, minus x on both sides. Got x minus 11 equals 7, and then add 11, and x should be 18. So I'm going to click on 18, then I'll move on. I think it's a good idea. If you want to, go ahead and plug that in and make sure you do get the same things on both of them, just to double check. So there's that one. The word bisect, cut in half. Okay, vocabulary again. L, M, and N are collinear. Collinear means together on the same line. Now, this question is kind of vague. I wish it had more detail, but here's the idea. L, M, and N, somewhere on the same line. says LM is 17. So LM is 17. Okay, and be careful with what it gives, the information it gives you. So then it says LN is 29. Well, LN is this whole segment. It's 29. Well, if this is 17 and the whole thing is 29, we're going to go 29 minus 17. Okay, and 29 minus 17 is 12. So the question is, what is MN? MN is 12. Add those two together, it should be 29. So that should be 12, and we'll go to the next one. Okay, now this one, you got to pay attention to what it's telling you. Again, it says QT bisect. That's a key word, bisect, because it means it's going to cut in half. So when I see that, QT bisects RQS. RQS is this thing right here, RQS. So I have QT that bisects it. Now QT is not on the diagram. So I got to make QT. So Q and T bisect that RQS. That means these two angles are going to be the same. So it says, the question is, what would the measure of one of the resulting angles be? What means is, which one is it? Is this, this is QT. TQS, I can give them that one, or RQT. Either way, it's going to be the same answer. So that's why it asks, which one is the resulting angle? So here's what I got. Here's what I know. I'm going to erase that for now. Okay, I'm just going to, so I got linear pairs. I got 3x plus 5 and x plus 3. I wish it told you it was a line, but it is. It's a line. So what I know is I add those two. That has to equal 180 because 180 is a line. So once I get that, I can plug that in for x. Once I get x, I can plug it in here. Then I can take half of that because that's a bisector. So I'm going to solve this real quick. That's 4x plus 8. That was 8. 172. So if I divide by 4, I get 43. All right, so it doesn't want to know what x is. Again, pay attention to the question. It says, what's the measure of one of the resulting angles? Well, if I do this, if I put 43 in for x here, this whole angle is 46 degrees. Now, the next question after this, we can go ahead and answer this now, is what is this angle? Well, if that's 46, and I got a linear pair, it's 180 minus 46. This is actually the next question. Okay, so that's 134. All right, but let's go back to this question. Go back to the original. If this RQS is 46 and this QT is going to bisect it, that means each one is 23, half of 46. So that means this would be 23 degrees and this would be 23 degrees. Okay. So be careful with that one. A lot of people would put either 43 just because that's what x is, or 46, but you got to read the question and know what it's saying. You got to understand the word bisect, what bisect means. Okay, so 23 will be the answer to that. You're going to have one just like it on test, so just be careful. Okay, the next one, same idea, right? We just worked this one. Same x plus 3, same 3x plus 5. We got the x. If you remember, this was 46 degrees. 180 minus that 46 got us this one, which is 134. Okay, so if you need to rewind and look at that again, then do that. All right, last one on the review. Line segments. All right, you had a test on this. So I got segment DG is R plus 3. I got segment GM is 4R minus 28. And in the statement, if dm is 45, well, dm is this whole thing. So it's pretty straightforward. I got R plus 3, that segment plus that segment is going to give me the whole thing, which is 45. So and the question is, what is the value of R? So I just solved this for R, and we're good to go. So I'm going to go kind of fast. I got R and 4R, that's 5R, 3 minus 28. Be careful with your negatives. And then when I add 25, I get 70. And then 70 divided by 5, if you want to work it out, you can.